it comes from. Okay, so we already know what is system and surrounding. We'll already discuss what there are different type of system, all those things. So here, what we are going to do, you will get, you have to take 100 ml of water, which is 100 gram of water, and check the initial temperature of the water. After that, I will give you an unknown sample of the metal with a higher temperature. I will boil the metal for a specific temperature, and you will know the final temperature. Sorry, initial, not the final temperature. You will know the initial temperature of the metal, and you are transferring that metal into this water, and close this and check the thermometer for the temperature change. So what will happen, we know that this is hot and water is cold, so the temperature will flow from heat to hot to cold until they will become thermal equilibrium, right? So both of them will reach in same final temperature, that is both will be the part of the system, and they will become same temperature. So what you are going to do, you are checking the thermometer, the temperature will gradually increase, and it will reach in a specific temperature, and it will stay there for a while. So that is, that's the time we are checking the final temperature. So once you get all this, you are going to calculate. So we know the specific heat of water, right? And you know the initial temperature, you know the final temperature of both of that. And you are going to calculate this specific heat. We'll use the weighing method. So get the metal, once it is cold, get the metal out of the water, dry it, and find the mass using the weighing balance on the back of the classroom, and you have the mass, so then you can calculate the specific heat. Once you calculate it, compare your answer with this table. You will not get the exact value because we are using a styrofoam cup, and you are opening, and maybe there is a lot of heat is losing to the surroundings, right? So you will get a value which is almost closer to one of the values. So you can then, okay, if your answer is something closer to this, you will identify, oh, my unknown metal is aluminum, like that. Okay, and this is the equation. We know that according to the first lab thermodynamics, total energy is conserved. So Q lost plus Q gained by water will be, both will be equal to, both will be same, so that their sum will be equal to 0. So here object is losing heat, so this will be negative, the other one will be positive. You have to correct that first. This will be negative, this will be positive. Okay, so that is the equation you can use, then answer these questions based on your answers. So I'm gonna do one question from this, maybe two question, I don't know. So I'm gonna do these two questions, and then we will, instead, this is a practice, this is a homework, right? So I already made a review because this practice didn't cover some of the question which is you will see on your test will be asking for T final. That is not in this practice, so I made a separate review. Once I record this video, I'll do that. Okay, so let's do this question. Okay, so we are using the equation Q lost plus Q gained equal to 0, or you can do, if you need to do step by step, you will write Q lost is equal to what? Q gained. Okay, so here there are two objects. One is metal, as like your lab, metal is losing and water is getting energy. So first we are going to calculate the heat gained by the water. So that is Q is equal to M times C times delta T. So we need all of this for water. This is 150 gram of water. So you are going to write 150 gram of water times C of water. If it is not given in the equation or in the question, you have to look at your formula sheet. This is given on your formula sheet. 4.18 joule per gram degree Celsius times delta T, which is T final minus T initial of water. Okay, so final temperature of both will be 25.0 and 45.0, right? This is the final temperature and initial temperature is 25, so difference will be what? 20. I'm going to keep the sig fig correct, 20.0 degrees Celsius. Okay, so now you will multiply all of this, and then why I wrote all this unit. See, you have to understand how the units are cancelling and what is the unit you are getting for your final answer. So that will be joules, right? So you will get 12,500 joules. Okay, now it is asking how much heat is lost by the silver. You don't need to do a calculation. We know that whatever is gained by the water, that is the same value for a metal. But only difference, it is losing, so you are adding a negative symbol there. 12,500 joules. Okay, now the next step is determine the specific heat of the silver. So again we are using the equation Q is equal to M times C times delta T. Now all the values for the metal. Okay, Q for the metal is 12,500 joules, which is negative, and mass of the metal, which is what? 85.0 gram. 85.0 gram times C, we don't know, delta T, the final temperature is 45.0 degrees Celsius minus the initial temperature of the metal is 622.0 degrees Celsius. Okay, so you have to subtract this first, then multiply those values. If you want to do it, I will do it. Okay, let's cross the units out, so we don't need to. Yeah, units are staying, it is not crossing out. Okay, that's good. Okay, it's good. So you are going to multiply 85 times what is 622.45 difference. What do you calculate that and get a calculator? Then 45, so that is 577, and the units are, there is gram and degree Celsius here. 577 times 85 is, this will be negative, right? This negative and this negative cancel, so don't worry about the negative. So 3000, when you multiply you will get 3203. Then you are dividing that with that. Okay, then your final answer will be, your final answer is 0.256, and there was a joule and then you divide with the gram, so 256 joule gram degrees Celsius. That is your final answer. Okay, so the same way you can do the second question also. Here there is, first you are calculating Q of water using M times C times delta T, which is mass of water is 50.0 gram times C of water. It is not given in the question, but you can use your formula sheet or use the previous question to find that, and the temperature difference is 35.2 minus 23.0, which is what? Which is 12.2 degrees Celsius. Then multiply all of that, then you will get Q of water is equal to 2550 joules. Then Q lost by the metal will be the negative of that number, which is 2550 joule, right? Okay, now same way calculate the, like this question you are calculating the specific heat. Q is equal to M times C times delta T. We got the Q, which is 2550 joule, and mass of the metal, don't confused with that. Okay, you need mass of metal there. Then C, then delta T, this time the final temperature is 35.2 minus 141.2 2 degrees Celsius. Okay, now calculate it. So get to the calculator. 2 minus 35.2, so this will be 106. Okay, you are multiplying 106 with the 55, you will get 5830C. So then C is equal to the negative, this will be negative, this negative and this negative cancel. So 2550 divided by 5830. This is joule, this is gram degree Celsius. So your answer is 0.437 joule per gram degree Celsius. Okay, that's how you are doing it. So these are the practices. Okay, you are going to do this as a homework or a review for the test. Okay, so this one doesn't cover some of the question I already said, so I'm going to do that now. Let me go back and see. Can find it. Hey, I'm gonna do this questions, okay, which is calorimetry review. I made one. Okay, it's easy for you. Let me get it. Hey, let's see that. Let me pull the doc. Good. I'm trying to log into my device. So give me 1 second. All right, that's that. So we are going to do all of this question in like this format. We are going to do Q lost plus Q gained. Q gained is equal to 0. Okay. If you want to try that before me, you can. But if you don't know how to do, just watch me doing it. Then after that, just make one question like that, then practice it. Okay, so Q is losing by the metal and gaining by the water, right? So we are going to plug everything. So I'm going to write the equation m times c times delta t is equal to, when if you write a for everything, that's fine, the m times c of b, then delta t of b. Okay, like identifying this is a and this is b. That's up to you. If you don't want to do it, that's fine. So substitute everything. So we are going to write 50.0 times 0.385 joule per gram degree Celsius times delta T. Okay, we know the initial temperature of metal is 90, but we don't know the final, so we are going to write TF minus 90.0 degrees Celsius. Okay, that is maybe the difficult part, you will see. Okay, now the other side, the mass of water is 100.0 gram and specific heat capacity of water is 4.18 joule per gram degree Celsius. Okay, times again final temperature. I'm writing TF for both because it is asking final temperature. Both TF will be same. We know that they are in thermal equilibrium. TF minus, and the initial temperature of water is 20.0 degrees Celsius. So basically that's it, but it's in algebra. Some of you are struggling, remember last time. Okay, So I am gonna show you like a step by step. You can do whatever method you know. This is algebra. Okay, just follow the rules. So if you multiply this times this, you will get a 19.25. Uh, okay, so since it is losing, I'm gonna put the negative symbol here, negative symbol here, negative symbol here, or you can just write q lost is equal to q gained. Then we can solve that problem. Let's do that. That will be easy. Okay, just take the negative off. Just q lost plus. Okay, I'm gonna, instead of equal symbol, I'm gonna add a plus symbol there. So don't get confused with that. Okay, is equal to 0. Okay, this one is also equal to 0. Okay, 19.25 times TF minus 90 degrees Celsius plus 100 times 4.18. You don't need a calculator for that. It is 418. Just forget about all the symbols. Okay, we can units 20.0 degrees Celsius, right? Now we have to distribute this number outside. Remember, like a normal math equation, I'm going to click it. So like this, you will multiply this with this, right? Okay, you have to do that. So 19.25 TF, then minus 90 times 19.25 will be 1732.5 plus 418 TF minus 8360, and that is equal to 0. Okay, now I'm gonna add the same type of variable. There is this TF, just add both of them together. You will get 437.25 TF. Then add these ones together. Okay, so that you will get negative 100,092.5 equal to 0. Okay, now it is like in a normal algebra, like easy, right? So I'm going to take this variable on that side, so you will get 437.25 TF is equal to 100. I took that other side, or you are just adding that number on both sides. That's normal algebra. Okay, then I'm going to divide, use a different color, divide both sides with 437.25. This will cancel. So TF is equal to 437.25. Okay, so you will get an answer which is 23 point, let me calculate, 23.081, and based on the sig fig we need 3 sig fig. So the final temperature is 23.1 degrees Celsius. That will be the final temperature. Okay, so this will be the difficult problem. It's not difficult, since on progress check some of you are confused. So there are two final temperature and both are unknown. How can I do that? See, because you didn't think it. Okay, you have to think about it. Final temperature of both will be same, so both are TF. You can calculate like that. Okay, so next question is easy. You can do like a normal way or this way, whatever method you are seeing. Okay, so second question, let's go. Let me pull that. Okay. Okay, second question is calculating initial temperature of metal. Okay, that is TI. So TI will be different for both of them. Okay, so we can do like Q, first calculate Q of water, then find the negative of that. So that will be easy. M times C times delta T, or you can do in one step. Okay, that's up to you. I don't care. This question you can do both ways. The other one, that's only way. So what is the mass of water, which is 100.0 gram, times specific heat of water is 4.18 joule per gram degree Celsius, and final temperature is 30.0 degrees Celsius minus 20.0 degrees Celsius, right? So it's only 5 degrees Celsius there. Okay, now you are calculating, you will get 2090 joules. Okay, that is Q of water. Then Q of the metal will be what? Negative 2090 joules. Okay, now Q of metal will be equal to M times C times delta T, which is minus 2090 joules, and mass of the metal is 75.0 gram, and times specific heat capacity is 450 joule per gram degree Celsius, times delta T. We know the final temperature, right, which is 30 degrees Celsius, and we don't know what, we don't know the initial temperature, we just put Ti. Okay, so I will multiply these two numbers, then divide. Okay, then divide, so it will be, use a different color so you can see easily, don't have space. It will be 33.75 times 30.0 minus Ti, right, is equal to that, is equal to this. So I'm gonna divide negative 2090 joules divided by 33.75. God, I don't have space. So I will get minus 61.92, which is equal to 30.0 minus Ti. So Ti will be equal to 30 plus, what? 30 plus 61.92. So my answer is, you can round your answer. This is 30.0, so say fixed matter. So answer will be 91.9 degrees Celsius. That will be the initial temperature. So metal was at a higher temperature. Now you can just check your logic. Okay, this one I think we did a couple of questions, the same strategy. First to find the Q of water, then negative of that water will be Q lost by the metal, then times M times C times delta T. Okay, then multiply M with delta T, then C is equal to Q divided by, you are dividing with M and delta T. Okay, you can do. Okay, that's it.